Awesome. So today what we're going to talk to is embracing emerging technologies. We're going to talk about why this is important and how to practically do it. So if you saw Mark Ayala's talk yesterday on the main stage, and if you didn't, definitely check out the recordings because all the S4 recordings will be online following the event. But something Mark pointed out really well is kind of the evolution of how control systems have changed, right? And with every iteration and every change in that, it brought new challenges. You know, what things looked like before the first Modicon PLC to today, significantly different, right? How we do operations in the industry, how things work, the difference between running relays directly between everything and changing to the PLC was a big switch. When we look at cybersecurity and when we bring this over to industrial cybersecurity, if we look at where we are today, we have good kind of best practices, things like passive network monitoring. The challenge that we see a lot is, this is good observation on the network side, but, oftentimes that observation point's really stuck to, okay, where is this? How can I scale this out? How does this meet the operational realities of where I'm at? Can I afford the costs per sensor price of rolling it out, right? So when you look at passive, it's definitely a best practice, but realistically today, there's a lot of challenges to that observation piece. Firewall and segmentation, right? Limited access areas, vulnerability assessment with the validation, incident response teams. A challenge with this, right? This is what we do it, but we'll talk on next slide on the challenges with this being kind of all professional services driven approach. And then finally, security awareness and training. You won't get away necessarily from the education piece. But as we move into that challenge side, right? One big challenge we see today on that incident response side, you can try to do incident response in-house. A lot of the asset owners we work with have dozens to hundreds of sites. They have maybe 2 to 7 incident responders total, and they're like, I'll outsource the problem. You go to most of the vendors, even the big ones, only have 7 to 9 incident responders. With the number of incident response retainers, many times more than the number of analysts out there, right? With this, there's a significant bottleneck at the response stage. If I pick up the phone, will that incident responder actually show up? We have a lot of uncomfortable conversations with asset owners on this, right? This isn't to knock professional services. This is a reality of industry. We often see too with that, right? What are the limitations to passive network monitoring? Do I have G's SDI protocol? Do I really understand Schneider's Unity protocol at a low level? Do I understand protocols that are kind of hard to get to, and how am I dealing with those, right? So again, when we talk about some of those challenges, when you're going with some of today, there's challenges. And so with that, and what we'll talk about later in here is how we struggle with this, right? You take those challenges and you bring it over to some of the sophisticated cyber threats, right? Volt Typhoon, living on the land, it's the big hot thing to talk about this week, right? How do you find that kind of built-in Windows functionality at scale, again, across dozens to hundreds of sites when you have such a small team? Again, resource constraints. We see that resource constraints on people in-house and kind of what's going out. And integration of IT and OT, we're not going to turn it into that kind of talk. And so the model that we propose today here, and when we talk about a model that we built here was, okay, let's look at how vehicles are changing, right? We're seeing more Teslas on the road. We're seeing more Rivians on the road. And so what you have here on screen is SAE's J3016, the foundations of car automation levels. Everything from level 0, you're driving the car, there's no assistant, there's no lane assistant, nothing through there, to where you get into level 1 and 2, different parts of the car are being driven for you, right? When you get to level 4 and 5, the car is driving itself, and level 4, it might be asking you for some input in situations that it's not comfortable, right? But the thing to point out is it's a spectrum. You don't wake up the next day and suddenly your Tesla full self-driving is full self-driving. Elon got in trouble for that, right? There's no full self-driving out there. But there is a spectrum on how this is being applied, right? Mercedes, I think, is getting close to a level 4. They think they'll be there by 2030, right? But again, there's a framework for dealing with this. in J3016, the last thing that I'll take out of the spec so that SAE doesn't sue me for putting it up on stage, what we have here is that journey. So from the start to finish of you driving your car, that level 0 is manual driving. It's all you, right? To where that level 2 gets you to, hey, you're manually driving, but now your Tesla or your other EV will actually overtake someone without you having to take control, right? You get down into the lower parts, those bottom 3 lines, right? You have the car can park itself. You have this idea of, hey, I can tell my car to come pick me up at work instead of my Uber, right? Or I can send my car somewhere else to go pick someone up, right? So we're looking at, we're kind of living in the age, and we're looking at how electronic vehicles, how EVs are actually changing and the automation on those. Something that we want to propose in this talk, and something that we've put out a little bit now, is trying to apply levels of automation to industrial cybersecurity. Again, with self-driving cars, you have to be safe, right? Because it's still lives that are at stake. There's still things that you have to be very careful from a safety system perspective and others. But you can build a similar model, right? To say, hey, in level 0 to 2 of automation for cybersecurity, you're still doing the triage as an analyst. You're still dealing with alerts. You're still doing that correlation. In level 0 and 1, you're still providing support to the automation, right? When you talk about things like AI, right, and some people will roll their eyes and say, oh, we're losing AI. Where AI is actually probably going to help us the most is it's going to start to get our security operations up some of these levels to where the system's making more decisions. Now, again, I'm not saying that we're going to pull the human out of the loop sooner than later, right? But what we see is we're going to kind of see that phase to where we see automation taking more and more control, maybe with a little less supervision on there, right? And then when you get to levels 3, 4, and 5 on the top of this, right, it gets into that collection phase. It gets into that correlation and triaging. One of the big challenges we deal with this too is, again, to that low number of incident response folks, low number of cyber folks to plants, is the challenge of how to, if I have 12 plants that get popped and they're geographically spread out, how do I deal with that, right? For most asset owners, that's still driving out there. You might be able to send a plant manager a thing and be like, hey, run this, upload the logs, we can try to do that. So when I was in the Air Force, I worked for the Air Force CERT. We would do that. We'd send out triage scripts to our bases that got popped. It would take them 2 to 4 weeks to send the artifacts back for us to actually do the incident response. 2 to 4 weeks can be a long time when you're doing incident response or threat hunting. But again, at that, with the Air Force CERT, we were dealing with 2.5 billion assets, 800,000 users, massive network. You still can begin to scale to hit some of this problem that, hey, will we actually be able to respond knowing that we have this really hard gap in here? All right. So final one, or actually before we get into specific cases there, again, on the model as you look in these slides, right, when we look at levels of automation, we are technically, for passive network monitoring, we're not at a level 0, right? People aren't pulling packets off the wire in Wireshark, looking at them. They're using tools like Dragos, Nozomi, Clarity, one of the passive network monitoring tools. So to a certain point, part of what we're doing in our operations really are at level 2, right? And what we're kind of pushing with this is how do we again get that scale to where we can do more prevention, threat hunting type stuff, response type stuff without, with scale and being able to push out more. So what does this matter to industrial cybersecurity, and what does it look like? Today, using NIST CSF as a backbone, right? We would argue for Identify that we're at analyst supported, right? There are tools out there that are doing risk analysis. There's tools out there doing asset ID in different ways. So there definitely are tools that are helping do that. There are tools that are starting to come in to help more with sophisticated tabletop exercise building. Clint, I think, might have a talk here on that. I know he's done it at a few other conferences, right? But again, we kind of argue that that part of NIST CSF probably is at analyst supported. With Protect, we're seeing a lot of it as being manual. When we get into Detect, again, because most venture capital funding in the industrial space has gone to passive network monitoring, we see probably that as being one of the heaviest from analysts supported, because there are so many passive network monitoring tools, because that's where the investment has mostly gone. But again, it drops off very quickly when you look at response and recover to that point of needing people to actually scale to go out, or just not having people to go out there. So how do we actually improve it, and why does it matter? And identify, even today, like we said, there's a lot of asset ID tools. There's a lot of the vendors are here showing things one floor up on these. Identify today is really focused right on, can you get me firmware version? Can you show me maybe what's behind that Modbus gateway? Can you show me certain things? But when we talk about this getting more automated, to us, what would be really interesting is for it to be super process aware. And so Mark Johnson-Barbier from SRP, he's sitting up here too, we did a talk at Pi World in 2018 on can we take Pi historian event data frames and try to correlate with those with cybersecurity incidents, right? A cool thing at Identify would be not just to say, hey, what is this make and model of the PLC, but can I actually pull in operational data? Can I actually see parts of my process change before I know it? We were at breakfast with someone yesterday. We were talking about smart things, and he was like, yeah, my smartwatch told me I had COVID before I even knew, right? And so that, and that would be more detect, right? But that deep understanding on Identify, getting to that lower level, with automation, what it's going to enable us to do is get into that deeper level of network and host data to where we're actually able to correlate and make more sense than what a human can do today. Moving Protect up, this gets into those risk estimation frameworks. There's a lot of ways that we're estimating risk. At the same time in the industry, we're seeing movements in things like CIE, right? And mapping this to, mapping that understanding to also, again, the deep process understanding of your plant. This is where Protect, through automation, we think will probably push more towards, it being tailored than it kind of being a high level, industry-wide view of risk, right? So it being more tailored with that. With Detect, right, and we talked about this being a heavy area for analysis, and because so much time and effort in the community has gone into it, right now today, if you look at how incident response works, and you look at how threat hunting works, both at the professional services organizations, the vendors, and even internally, still a lot of the analysts are having to actually correlate host and network data together. It's kind of a silo that's often the humans having to fill, right? We see to that point the silo actually having to come together, because if you look at the MITRE ATT&CK framework, the network data is only going to get you so far, right? Host data will only get you so many MITRE ATT&CK techniques, and sometimes you need the context of both to actually work through a threat hunt or work through an IR case, right? So the ability to automate some of that data analysis, pull it in, have it deeper in there, means that we'll have a more holistic view and a deeper view that helps us move a lot quicker. On response, right? We talked about reliance on MSSPs. We talked about, hey, what happens if I call that IR retainer and they're saturated? This is a key area, and it's an area that as we work with some asset owners, they're concerned about, because they realize that some asset owners are like, hey, we're getting multiple retainers, we're kind of doing these other things to make sure someone actually shows up when we activate the IR retainer, right? But again, moving it into software, moving it a little bit outside of people means that in that case that you get oversaturated, we'll still be all right, right? We see it moving into software and tools in that space to allow that to scale. I was talking to a peer that he's out in one of the European markets, and he's like, we don't have enough people that understand OT in this market. It's a very small market. The players here, there's good talent. There's just not enough of us to really do response, to do incident response or do threat hunting. And dealing with that fact that we see here in industries in the US, as well as talking kind of globally, that's kind of a hard, unsolved problem that we see some of these emerging technologies, some of our ability to deal with larger quantities of data efficiently can do. By the way, this doesn't mean you have to go to the cloud, right? So we're not saying like all of this automation, it'll be cloud. There's even pushes to where like local LLMs, other models that can be done in a plant, can be done in a closed environment, and in the realities of industrial environments is likely possible. To recover, there are groups that are stepping kind of into this. We're seeing groups now that are looking in, hey, how do we recover? How do we store log file, or do we store configs in case they all get blown off of PLCs? What do we do on this, right? Using automation here, what's interesting is we've seen groups that actually kind of set up reactive kind of swim lanes or things on that to say, hey, in case this PLC gets entirely wiped out, let's just push the logic on it automatically without a human hitting that, right? And so to that point, as you actually get more sophisticated on the other end, what that does is actually open up the ability to respond quicker. I know there's actually some vendors out there too that are actually starting to build hardware devices that can rapidly reconstitute Windows machines, other areas. But to this point, what's important and what's going to be challenging for us as an industry is dealing with both the scale and the complexity, right? How you do it in a refinery versus how you do it in a substation or a generation plant, there's kind of different variables you have to deal with in those, right? But when you talk about responding and recovering quickly, there's room kind of, we think, as through the automation framework and as you think and as vendors actually implement through that, to push that up and to actually improve there. So a question that we have, right, because you say automation, you say certain things, it's like, how do we get kind of all of them to being autonomous? And the truth is, our jobs are safe, right? We're not going to go anywhere. It's going to take a long time for all of NIST CSF to be entirely automated, right? But that doesn't mean that we should try to pull off some of the areas that are high risk or don't scale and try to push that into automation. So that's my talk today. If there are any questions, there's a mic up here, but yeah, thanks for attending. Awesome. Cool.
Do you see in general a shift in terms of framework direction to NIST for automation, away from like 62443?
So we see a mix, and some of it depends on the client. Are they using 62443 or NIST? We like NIST because NIST was actually written for OT in there, but 62443 would be another actual, valid way to think through it also. Yeah. Yep.
Just want to make a comment on that last question.
Oh yeah.
And the last response. So there's some nuance there that I think we have to appreciate because NIST is not a standard.
Yep.
NIST is a framework and it's a best practice. It's recommendations. 62443 is an industry standard.
Correct. Yep. Awesome. Well, thanks everyone.